In this video, we'll look at solving a system of two linear equations with no solution or infinitely many solutions. So your process of solving will be the same as if you were doing a system that had a single solution. You can use elimination or substitution, but we need to be able to recognize what it looks like when you have no solution or infinitely many solutions. First, if the variables all cancel out and you get a contradiction when solving, that means that the system has no solution, meaning that the lines are parallel. And you could actually check this by solving both equations for y and seeing that they have the same slope, but different y-intercepts. Let's look at this example and solve by elimination. So we're going to solve by elimination. With elimination, I want to get both equations in the form ax plus by equals c. So I'm going to go ahead and do that for the first equation. I have 4y equals -1 plus 8x. And I'll go ahead and subtract 8x from both sides. So that equation becomes -8x plus 4y equals -1. And my second equation is already basically in that form, but I have to move the x term to be first. So I'll rewrite it as -6x plus 3y equals 3. So remember, with elimination, what you want to do is pick a variable to eliminate first. And it doesn't matter which one you pick. You can pick the x or the y, but you do have to choose. So if you're choosing, that will inform what to multiply each equation by. So let's say that I choose to eliminate y. Then I want to multiply the first equation by a number and multiply the second equation by a different number so that the coefficient on the y is the same number but opposite signs. So I could multiply the first equation by a 3 and the second equation by a -4. And then when I distribute, that would give me a 12y for the first equation and a -12y for the second equation. So every term gets multiplied by the number that you're multiplying the equation by. So the first equation becomes -24x plus 12y equals -3. And the second equation becomes +24x because I'm multiplying everything by -4. So +24x minus 12y equals -4 times 3, so equals -12. So now when I go to add my equations together, I can see that -24x and +24x are going to cancel each other out, and +12y and -12y will cancel each other out. And so what I end up with is 0 on the left-hand side of the equal sign and -15, because I'm adding a -3 and a -12 together on the right side of the equal sign. Now 0 is not actually equal to -15, so this is false. Another way to think of that is that it's a contradiction. So notice that all the variables went away, and I ended up with a contradiction. 0 equals -15. And so that's what tells me that there's no solution to the system of equations. So because of that contradiction, I would say that there's no solution. And another way to think of that geometrically is the lines are parallel. So there's no point where the two lines cross each other. Now, if you wanted to check that, you could go ahead and solve both of these for y. So if I wanted to check that they're parallel, the first one is already in the first one already has the y term by itself on the left side. So I could just divide everything by 4, and I would end up with y equals 8x over 4 would give me 2x. And then minus 1 over 4 would give me minus 1/4. So that's the first line. The second line, I would add 6x to both sides. So I get 3y equals 6x plus 3, which would simplify to y equals 6 divided by 3 would give me 2x. 3 divided by 3 would give me 1, so 2x plus 1. So you can see that these two lines have the same slope, but they have different y-intercepts. So they're going to be parallel to one another and never cross. Desmos is actually really good at visually checking when you get no solution or infinitely many solutions. What you would do is you would pull up the graphing tool, and you can put in the equations exactly as you see them. So I could put in the first equation as 4y equals -1 plus 8x. And the second equation I could put in as 3y minus 6x equals 3. And you can see those two lines are parallel. They have the same slope and they never cross one another. So no solution is correct. Now, don't get in the trap of always graphing in Desmos to figure it out, because you do have to show your work on these on the test in order to earn credit. So Desmos is for checking after you've done the work. So after you've done the process of elimination, you can check with Desmos. All right, now the next possibility is if the variables all cancel out and you get a true statement, then there are infinitely many solutions. So a true statement would be infinitely many solutions. And in this case, you would answer, there are infinitely many solutions. The solutions must satisfy the following equation. And what you would do is you would solve the equations to be in the form y equals mx plus b. So whatever equation the two of these end up being, that's what you would put in this fill in the blank. So let's use the process of elimination here. I have 2x minus 1/3 y equals 10. And I have -6x plus y equals -30. Now I'm going to pick one of the variables to eliminate since I'm doing elimination. So if I wanted to choose, I would go ahead and eliminate x. Remember, it's a choice. You could choose y instead. If I want to eliminate x, what I could do is multiply the first equation by 3, and that would automatically give me the 6x, which is already the opposite of the -6x. So when I distribute that 3, I'll get 6x. 3 times -1/3 would just give me minus y. And 3 times 10 gives me 30. So 6x minus y equals 30. The second equation, I'm going to leave it as it is because that will already cancel the x's. So -6x plus y equals -30. Now check this out. Everything is opposite here. 6x minus 6x is 0. Negative y plus y is 0. And 30 minus 30 is 0. So I get 0 equals 0. So all the variables went away. The variables canceled out. And this is true no matter what value of x or y I use. 0 is always equal to 0. And so I would say that there are infinitely many solutions. And now I have to figure out what to put in this blank. The solutions must satisfy the following equation. So what I'll do is I will take my original equations. So I have 2x minus 1/3 y equals 10, and I'm going to solve for y. So I will subtract 2x from both sides. So I get negative 1/3 y equals negative 2x plus 10. And then I'm going to multiply everything by a -3. So I take this side, I'm going to multiply by a -3. I take this whole side and I'm going to multiply by a -3. That will clear out the fraction on the left. So I get y equals 6x minus 30, because that -3 gets distributed there. Now let me take the other equation, negative 6x plus y equals -30. All I have to do there is add 6x to both sides. And so I get y equals 6x minus 30. These are the same line. Geometrically, that's what it means when there are infinitely many solutions, that the two lines are actually the same. So you would say all solutions satisfy y equals 6x minus 30. So all solutions must satisfy y equals 6x minus 30. And that's how you check to make sure there's actually infinitely many solutions, is solve for y. Get in the form y equals ax plus b. So remember, for no solution, it's when you get a contradiction, like 0 equals -15. For infinitely many solutions, it's when you have a true statement, like 0 equals 0.